Now, just like with line integrals, we can also calculate surface integrals of scalar valued functions, functions that give us some kind of like a density of some quantity. If we've got a surface inside three-dimensional space and it's heavier in some parts than in other parts where the weight is given by some density function, we can total that up. And the way we total it up is just like doing a surface area calculation, except we throw this factor out in front. We throw this value of the function at our current position. So this is density at current position. And we also have to keep our area factor, like so. So for example, we can use this to find the total mass of a surface whose density varies from point to point. For example, let's suppose we have a density function f of x, y, z is equal to yx cubed, and we want to find the total mass of this surface. Z is equal to x squared, where x is between 0 and 2 and 0, y is between 0 and 1. In this case, this is still the graph of a function. It's the graph of the function g of uv, where g of uv is equal to u squared, because z is equal to just x squared. So first, our parameterization, phi of uv, is u comma v comma u squared. And so we're supposed to be calculating the double integral of our function yx cubed evaluated at this point. So here we're going to get v times u cubed. This is f of phi of u comma v. And then we're supposed to multiply it by the area distortion factor. But the area distortion factor, because we've got the graph of a function, it's still the square root of 1 plus the derivative of g with respect to u squared plus the derivative of g with respect to v squared du dv. And so this is going to turn into a double integral of vu cubed times the square root of 1 plus 4u squared du dv, like so. And we're going to be integrating this, since u is our x coordinate, that goes between 0 and 2, and since v is our y coordinate, that goes between 0 and 1. So that's setting up the double integral. And this particular double integral is, in some sense, doable. And so we could continue this calculation if we want. But the main step here is to make sure that we have both the area distortion factor and we also have the factor for density out front. All right.